Model explanation. The objective and purpose of my model was to accurately represent the mechanism by which tectonic plates collide and form fold mountains, particularly the continuous process of collision exhibited at the boundary between two convergent plates. To achieve this, I've implemented the use of two triangular prisms labeled tectonic plate number 1 and tectonic plate number 2. The labeling of the flat face of tectonic plate number 2 was with careful consideration. This labeling represents the site at which ridge pushing takes place. Ridge pushing, along with the movement of convection currents, is the driving force by which a convergent plate forming a mountain can occur. Convection currents being the rising, spread and sinking of gas, liquid or molten material caused by the application of heat from the Earth's core. Furthermore, when tectonic plate number 1 and tectonic plate number 2 collide horizontally through the user exhibiting a pushing motion, the flat box labelled mountain formed by tectonic plates will protrude upwards between them. This is designed to show the motion of land matter present at a convergent plate boundary. Mountains can form when two convergent plates merge together. If these plates have equal height, weight and mass, they will buckle and fold under pressure. This converging motion forces rock and sediments upwards, forming mountain ranges. Justification of material choices. In my model design, I have implemented the use of a multitude of different materials to fulfill my vision of a design representing the convergent movement of tectonic plates, forming geologic landforms such as mountain ranges. To build the structures labelled as tectonic plate number 1 and tectonic plate number 2, I used 3mm plywood to construct the flat back and sides of the triangular prism. And to finish off this element of my design, I used flat balsa wood for the top and bottom of the tectonic plate. This, coupled with the use of PVA glue, meant I was able to construct what I intended. The use of balsa wood as a material far exceeded my expectations. It provided a much stronger support when gluing components together. This is ever important in a practical model which requires its users to physically interact with the model. Using balsa wood and plywood means less likelihood of breakages compared to the alternative of cardboard. In addition to this, balsa wood is also highly environmentally friendly as it grows very quickly and is very sustainable. Regarding the construction of my display board, I implemented the use of 15mm thick plywood. This plywood provided a sufficient space which was large enough to glue all of my various QR codes. Furthermore, I believe my design choices have had a distinct impact on the overall aesthetics of my design. Interactive feature. In my scientific model, the concept being modelled was the collision of convergent tectonic plates forming mountains. The interactive feature of the model is the sliding motion which is undergone on wooden beams. This feature allows the person handling the model to visually interpret how the convergence of tectonic plates can form mountain ranges in a simplistic fashion.